So last we talk about the derivative, and at the end, we also talk about the arc length. We start talking about polar coordinates here, remember? So basically every point has one, the first coordinate is the radius, the second coordinate is the angle. And then we were converting points, we were graphing actually. We were graphing these points in polar coordinates, okay? So where were those points in polar coordinates? So that's what we did last class. And that this was an important example. If the radius can be negative, and then if you do 3 pi fourths, so you move the angle 3 pi fourths, and this is positive 3, then you have to go negative 3, okay, in this direction. Okay, so that's what I want to mention this before going to the next part of polar coordinates. Okay, so what we can do also, so there are two formulas. This is kind of, you saw this in pre-calculus. There are two formulas for going from triangular rectangular coordinates to polar coordinates, and this was this. So you can do x equals r cosine of theta, and y equals r sine of theta. Okay, so this is coming from the circle. Remember, we said if you have a circle, this case the radius is r. This point is r cosine theta, r sine theta. So polar coordinates are coming from basically from the circle. Okay, so this angle is theta, and then that's the radius. So let's say you are in x in rectangular coordinates. So you ask me, what is this? What is the? How can I write that point that is in rectangular coordinates? You see, this is rectangular coordinates. How can I grab this in polar coordinates? So you just find the radius and then find the angle, and then that will be r and theta. Okay, so those are the formulas we have. So from the circle, I got this formula. Okay, x equals r cosine theta, y equals r sine theta, and from here I get the following. I got r squared equals x squared plus y squared, and the other is tangent of theta is y over x. Okay, because this is y, right? And this is x. So the tangent is opposite angle over adjacent. So you see those two formulas are totally natural. Okay, and that's what we're gonna use to change from one coordinate to the other coordinate. So for example, convert the point to example. Convert the point to 2 pi thirds from polar to Cartesian coordinates. From polar to Cartesian or rectangular. Those are the same. To Cartesian coordinates. Cartesian or rectangular are the same. Okay, so what you have here is r equals 2 and pi thirds equals theta, right? So you know what is R, what is theta, so you will use this formula. Oops. You know R, you know theta, so you use that formula. So R, X is R cosine theta. So we got R is 2 times cosine of theta, cosine of pi thirds. So this is 2, and what is cosine of pi thirds? Let's remember. You guys remember how do I do 60 degrees? I think if I'm not wrong is square root of 3 1 and 2. Is that right? No. Let's see. Might be 2. Yeah, it must be this one. 2 square root of 3 and 1. Because by Pythagoras, c squared equals a squared plus b squared. That will be 4 equals 1 plus 3. So that's good. So 60 degrees, cosine of 60 of pi thirds, that is 60 degrees, is 2 times cosine of 60 degrees is adjacent over hypotenuse. So that'll be 1 over half. So x should give you 1. Okay. Now y is r sine theta. So r is 2 sine of pi thirds. Sine of pi thirds is opposite over hypotenuse. So that will be 2 times square root 3 divided by 2. That equals square root 3. Okay. So in these 2 pi thirds in rectangular coordinates is x1 square root 3. So this guy 1 square root of 3, let's say this is square root of 3. This is 1 square root of 3. But in the other coordinates, this guy was 2, and the angle was pi thirds. So basically, you need to make a triangle, okay, to figure out the corresponding point, okay? So now another example, example 2. This kind of a review of precalculus. You saw this in precalculus. So represent the point with Cartesian coordinates (1 minus 1) in terms of polar coordinates. In terms of polar coordinates. So we have x is 1, y equals -1. So you just look at the formulas. So you have x, you have y. So you have to use this guy, right? So we have to use r squared. R squared equals x squared plus y squared. So r squared is 1 plus 1 is just 2, right? So r equals, so this is important here. that will give me like plus minus square root of 2. Okay, but because it's 5/3, probably I just choose the positive. And then to find y, I use the other formula that is telling me tangent of theta equals y over x. So tangent of theta equals y over x. So we will get tangent of theta. Theta is what do we say? Oh, we don't know. We don't know theta, right? So y is -1, x is 1. So we use our calculator and then find theta equals the arctangent of -1. So the arctangent of -1 is okay. So yeah. So let's do something first before. So let's place the point is 1 and -1. X is 1 and y is -1. So my point x1, y is -1. So this is the point, right? Well, here the point is here. So the point is in the fourth quadrant. Okay. So that's why when you find the arctangent, you need to make sure you are looking in the fourth quadrant. So you probably you could choose minus. You could choose minus pi4, okay, or the same that is 7 pi4. Both are the same, guys. So minus pi4 is measuring in this direction, and 7 pi4 is being measured all this way. Okay. So you just use your calculator, but then you have to fix it a little bit for the sign. Okay. But it's just calculator thing. This is pre-calculus, so you guys are familiar with that. Okay, so now we move to the real thing. So we're gonna do some calculations with polar coordinates, but we're gonna call it polar curves. So the graph of a polar equation R equals f of theta consists. So notice that this is different, right? Because compared to the usual is y equals f of x, right? This is rectangular or Cartesian coordinates, rectangular. Rectangular coordinates. In this case, this is polar coordinates, you see? This is nice. R equals f of the angle. Okay? So this consists of all points P that have at least one polar representation that have at least one polar representation r theta whose coordinates satisfy that satisfies the equation. That satisfies the equation. Okay. So this is kind of interesting. So for example one. So we're going basically what we're going to do is graph here. Example one. Graph the equation r equals 2. So what you do, you place theta and then you place r of theta. That's basically your function. Okay. Or you want it's the same thing, right? F of theta. You can call it f of theta. It's just like when you call it y f of x, right? You could just say y equals y of x, right? For some reason, we don't do that. We like to say f, right? But either way, because y depends of x, but we prefer to say y of x. So we say this is f of theta equals r, right? So give me an angle. So what angle do you guys give me an angle? Theta.
180.
Well, so remember, we're not doing that angle has to be in radians. So 180 degrees is not really, it's an angle, but it's not in radians. So I need
Pi.
that's
Pi.
pi. Yeah, there you go. So you do pi. So when you plug in pi over here, what do you get in this equation? The equation is, so let me put it like this, without fear. Right? We don't have to live in fear. This is r theta equals 2. What is the radius? What is r of pi?
2.
2. There you go. So give me another angle.
3 pi fourths.
3 pi fourths. So what is the r of angle of that angle?
2.
2. And so on. You give me any angle, all of them is 2 because it's a constant. Okay, so let's see how is the graph. So you tell me, you gave me pi, right? You give me pi, so I'm gonna do pi, and then I obtain the angle is pi, right? I'm gonna obtain 2. So my distance from here to here has to be 2. So now you give me 3 pi fourths. So let me choose another color. Now you give me 3 pi fourths. So 3 pi fourths is, well, let me do first pi fourths. Pi fourths is this one. Pi fourths until here. This is my angle. And my radius is 2. So now you give me 3 pi fourths. So 1 pi fourths, 2 pi fourths, 3 pi fourths. So any idea what it's gonna be? What is the distance from this point to the center?
2.
2. So it doesn't matter the angle, the distance is gonna be the same. So all these points must have distance 2. And all these guys must have distance 2. So what we're graphing is a circle. So r equals 2 is a circle of radius 2. as I said, you move in circles. Okay. Okay, so another example. We're gonna do example 2. Theta equals 1. So here, this one is probably a little weird, but this means the graph, basically my graph, right? My graph is all the couples, theta r, right? But what is theta? Theta is already 1. So I know my 1. I know this. So this is 1. And radius is any number, basically from minus infinity to infinity. Because it's no information about the radius, so the radius can be anything. Okay. So for example, so all these points, 1, 2, 1, 3, 1 minus, 1 minus 1, 1 minus 3, all those points belongs to the graph, because what is important is that the first coordinate is 1. So let's graph those. Those points are part of my graph. So the first one is 1, 2. So 1 is in the angle, right? So pi is like 3.14. So pi half is like 1.57 maybe, right? So I need 1. So you see this angle is 1.57 radians. So 1 must be something in the middle, right? My angle 1, my radian, because that's 1 radian. So that's an angle, okay? Is the angle 1 is 1, 2. So that's my angle, and remember, it's like shooting an arrow. So there will be 1, 2. So that point is over here. That point is there. The other is 1, 3. So okay, so my other point is probably here. So this is 1, 2, that's 3. So my other point is here. Well, let me make another color. So this is my other point. This is 1, 2. This is my other point, right? Then I want 1 minus 1. So basically, I mark my angle 1, and it's like they're living in the same line, because that's an angle, right? So it's like throwing an arrow. The other is 1 minus 1, so it continues in the same angle, but because it's minus, I move backwards. So I go move over here, minus 1. Sorry, let's see. No, it's not letting me. Over here. That one. That's 1 minus 1. So let me put it here. This is 1 minus 1. This one is 1, 1, 2. Oh, no, sorry. That was 1, 1. So 1, 2. 1, 2 is here. 1, 2. And this is 1, 3. So whatever has angle 1 is on my graph. So my graph is a, what do you guys say? It's a line, this line. So that's the graph of theta equals 1. Theta equals 1, 2, 3, 4, 5. Those are lines. And radius equals 2, 3, 4, 5. Those are circles. So that's what I was saying to you. You at any point, you are in rectangular coordinates, and you give me 1 point. So I will tell you, okay, make a circle around that point, and then shoot the arrow. So I will have radius, and then I will have the angle. Okay, so that's how it works. Okay, so let's do. I want to show you. Yeah, so okay, so let me see how much time. I will have time. So we're gonna do this interesting one. Okay. Example. Graph or sketch the curve. Sketch the curve. Sketch the curve of R equals cosine of 2 theta. So we're gonna graph that. So ladies are gonna like this one. So we're gonna make a table. So I'm gonna choose it in a smart way. So I get some nice examples. So let's solve. How would I explain this? Let's do. Yeah, let's remember how it's cosine. Cosine, the usual cosine is like this, right? So let me make a little table here so you guys don't get confused. This is 0. This is pi halves. This is pi. And this is 2 pi. Okay? This is cosine. Cosine of theta. Just theta. Oh, well, no, yeah, let's just call it y equals cosine of x. Yeah, y equals cosine of x because it's in rectangular coordinates. Okay? So, but also I know this guy. This is pi fourths. And I know all the fours. So this is pi 4. This is 2 pi 4. Pi half is 2 pi 4s. I have 3 pi 4s. That is going to be here. Pi is 4 pi 4s. So pi is 4 pi 4s, right? Then I have 5 pi 4s that goes here. Then I have 6 pi 4s that is 0. Then I have 7 pi 4s that is going to be here. And then I have 8 pi 4 that is 2 pi. So remember also that pi 4s goes like this, right? So pi 4s is here. So what is cosine of pi 4s? Somebody remember cosine of pi fourths? We did last class. What is cosine of pi fourths?
Square root of 2 over 2.
Thank you, yes. So then, don't forget cosine of 0. What is cosine of 0?
One.
1. Let me put it, yeah, well, let me put it like this for now. Then this point, this first coordinate, no? I'm not gonna put the second coordinate because the second coordinate is cosine, but it's not the point for me to talk about sine right now. So then cosine of 2 pi fourths, that is p halves. Cosine of pi halves is
0.
0, the first one, right? It will be 0, 1 in this case for sine. This one is sine raised square root 2 over 2, and this one will be 1, 0. But I care about the first one because that's cosine, right? Cosine, cosine, cosine. But what I did this, because with this, I can figure out all my pi fourths and all that. Because then this one is 5 pi fourths. All the here is 5 pi fourths. What is 5 pi fourths? Cosine of 5 pi fourths. Use that as a circle.
Is it negative square root of 2 over 2?
Yes, negative square root of 2 over 2, square root of 2 over 2 because it's symmetric. Now you do the same here. So by symmetry, what is this point? What is this point here?
Negative square root of 2 over 2, negative square root of 2 over 2.
Correct, yeah. But you have your calculator, so you don't worry if you don't, this is the hard way, but And then what is this point? This point over here?
Square root of 2 over 2, negative square root of 2 over 2.
Mm-hmm. All that is symmetry, okay? Okay, so all that to explain the following. So because I need more points. So since I had 2 pi, whatever I write is gonna be multiplied times 2. So I'm gonna put on 8. So I'm gonna put 0, 0, pi 8. Then I'm gonna put 2 pi 8. That is pi fourths, right? Then I'm gonna we're gonna write here 3 pi 8. Then I'm gonna write 4 pi 8. And I guess I can continue doing 5 pi 8. 6 pi 8. 7 8 pi 8. And 8 pi 8. So the ones that I know very good is 8 pi 8 is pi, right? 6 pi 8 is 3 pi fourths. So that's why I did this. But of course, you can use your calculator just to plug in. But I want to give you, this is pi halves. I want to show you don't need calculator, and for your precalculus, pi fourths. Okay. So all that you need to do is plug in, right? So this is your theta. So you need to do r equals cosine of 2 theta. So when theta is 0, what is r? cosine of 2 times 0 is 0, right? So cosine of 0 is?
1.
Cosine of 0 is 1. Next is cosine of 2 times pi 8. 2 pi 8 is cosine of pi 4, right? So what is cosine of pi 4? We put it here. Square root of 2 divided by 2. Yeah, so my next one is pi 4. So I have cosine of 2 times pi 4 is cosine of pi halves. What is cosine of pi halves?
0. No.
0.
Yeah.
Thank you. Then I have cosine of 2 times 3 pi 8. So that's cosine of 3 pi 4. So what is cosine of 3 pi 4? This one, minus the square root of 2 divided by 2. Minus. Then cosine of 2 times pi halves is cosine of pi. What is cosine of pi?
-1.
Negative 1. Then we continue. So let me make here like so it doesn't look that messy. Let me cross a line here. Oh, we're here. So we continue. Cosine of 5 pi 8. 2 times 5 pi 8, right? No? Will give me cosine of 5 pi 4. Cosine of 5 pi 4 is
Negative square root of 2 over 2.
yeah. Sorry, wait. Pi 4. Oh, I think I make a mistake here. I think cosine of 3 pi 4 I didn't do. Cosine of 3 pi 4. Yeah, sorry. Cosine of 3 pi 4 is not this one. Well, we don't. It's okay. We can skip that one. Cosine of 5 pi 4 we know. That is minus the square root 2 divided by 2. So we're almost done, guys. And then cosine of 2 times 3 pi 4 is cosine of 3 pi halves. What is that? Cosine of 3 pi halves is 0, because cosine of pi halves, 3 pi halves is 0. Then cosine of 7 pi 4, that is this one. So I'll get cosine of 7 pi 4 will give me square root 2 divided by 2. But of course, you can just plug in this in your calculator. I just, I'm just doing this. And then we have cosine of 8 pi divided by 8 will give me pi. So that's cosine of 2 pi. What is cosine of 2 pi?
1.
1. Thank you. Okay. So all these, just to graph it. Okay. So let's start graphing it. So this is the, probably I'm going to erase this. Let me erase this cosine over here. Everybody knows cosine, so I can erase it. So we're gonna start plugging these points. Okay, so let's go. Okay, so my first point is when my angle is 0, my radius is 1. Okay, right here. When my angle is 0, my radius is 1. So I'm gonna put 0. My angle is 0, so I need this point 1. Actually, I forget about the line because it's just a point, no? So let me erase this one. So that's my first point. My point, this point is angle 0. So this is 1, 0. My next point is angle pi force, radius square root 2 over 2. So, I had to have an idea what I'm doing. So this is pi force. Therefore, angle pi 8 is the middle one. So this is pi 8. What I need is a radius of square root of 2 over 2. So that's probably going to be somewhere probably here. Okay. And by the way, this is a little bit hard to figure out what is going on. But, I'm just trying to do the exercise of describing it little by little. So when so you'll see how these nice graphs are coming up. Okay. It's probably too much to ask you to graph this thing by yourself. Okay. So I'm kind of doing something very difficult to do. But the next one is when pi halves, at pi halves, that is pi halves is here, my radius is, what is my radius? What is my radius?
0.
0. So I'm here. So clearly I'm moving in this direction, right? So I try to fill up my points. I'm going this direction. So I'm going that direction, right? So I finish until pi fourths, but I have more. So the next one is 3 pi 8. Let me see. 3 pi 8 is the cosine of 3 pi fourths. So 3 pi fourths. Cosine of 3 pi fourths. Oh, okay, yes. I think yeah. So I was confusing a little bit because yeah, this is pi fourths. This is 2 pi fourths. This is 3 pi fourths. So that is indeed minus square root of 2 over 2. Okay. So I was getting confused with the 8s, but it's good. Minus square root 2 divided by 2. Okay. Is this one. Right? Yeah, it repeats. Yeah. So here I have angle 3 pi 8, that is 3 pi 8. Where is 3 pi 8? So we were saying this is pi fourths. Pi fourths was 2 pi 8, right? Pi 4 is 2 pi 8. This one, pi halves, is 4 pi 8. So 3 pi 8 is this one. Oh no. Okay. This is 3 pi 8 because it's between 4 pi 8 and 2 pi 8, right? It's between 4 pi 8 and 2 pi. Don't worry, we're almost done. And 2 pi 8. So this is 3 pi 8. So the radius here is minus the square root of 2 of 2. So instead of going positive, I go negative. So my point is here. My next point. That's my point. Okay. So the next one is 4 pi 8. 4 pi 8 is pi halves. So pi halves is this one. And then for pi halves, the radius is minus 1. So my radius is minus 1. So I have this point, I have this point, I have this point. So it's going like this. Okay? So if you continue doing this tiling exercise, this will be the first. This will be the first one. This will be the second one. The third one will go like this. That will be the third one. The fourth one will be this one. Fourth one. The fifth one will go like this. That'll be the fifth. The sixth one will go like this, and the seventh one will go like this, and then finally the eighth one will go like this. So it's like a rose. And of course, you know, it looks like a lot of work, right? But that's the real thing, okay? So you're gonna see spectacular graphs, for example, in the notes. In Wellwork, you have one. You just have to match the graphs versus the equations. But you know, you just need to check one point. You just check one point. You can check 1, 0, for example. And I bet you will figure out exactly which graph is the one that you need. Okay, you might need maximum 2 points to figure out what is the corresponding graph. But you just do this little exercise, so it will be much easier. Okay. Okay. It is kind of hard. I admit it's hard, but you know I want to show you the beauty of this. Is that like a new way to think, right? This R equals cosine of 2 theta. That's a rose. If you are a romantic, you can give it to your girlfriend or boyfriend. Okay. Hopefully they know some math. So. Okay, so now we saw that derivatives. So derivatives of polar curves. We already talked about this, but let's make a nicer formula. Derivatives of polar curves. So we already did this in the general case. So we said dy dx is in this dy dt, right? But in this case, we just call it theta. So dy d theta dx d theta. Okay. That was the general form. Instead of theta, we write t, but you know, t is the general case. Theta, we use it specific for polar coordinates. So what we need is to find the derivative. So I'm gonna do this to make your life easier. So you have a problem like this. You have x is r of theta times cosine of theta. And if you are planning to take calculus 3, this will be useful for your calculus 3. So we need to find, and this is why r theta sine of theta. Those are your polar coordinates. We usually don't write theta. We just say r, but we know that r depends of theta. Okay, so we are doing the real thing here. We're not pretending. So what is dy d theta? Dy d theta, the derivative of that is the product rule. So it's the derivative of the first one. So dr d theta times the second one without derivative plus the first one without derivative times the derivative of the second one. The derivative of sine is cosine of theta. Okay. And then for dx, same thing. So the derivative of the first one, because it's product rule, right? Times the second one without derivative plus the first one times the derivative of the second one is minus. The derivative of cosine is minus. So minus sine of theta. And that's your derivative. Okay. So that's what you use. I'll let you do this, but let's say, let me give you an example. Example 1. Oh, no, example no. No one, but example. For the, this is called for the cardioid. For the cardioid, r equals 1 plus sine of theta. Find the slope. Find the slope of the tangent line when theta equals 5 hertz. Okay. So what we need to do is use the formula over here. Okay, so we have, let's see if I can make it smaller to see the formula. Yeah, let me do it here right now. So we're gonna do dy dx is dr d theta. So that's the derivative of r with respect to theta. So you see it here. What is the derivative of r with respect to theta? Somebody there? Derivative of r with respect to theta. This is r. So we're trying to find this guy. Everybody knows that. That's cosine of theta, right? Times sine of theta plus r, that is 1 plus sine of theta, times cosine of theta. No, divided by. Now we do dr d theta, that's the same guy. I don't need to calculate it, it's here. Is cosine of theta times cosine of theta minus 1 plus sine of theta times sine of theta. So all that you need to do now is plug in at pi thirds. Okay, so you plug in at pi thirds. When you plug in at pi thirds all this in your calculator, you should get -1. Okay. And now they're asking find the slope of the tangent line when, yeah, okay, so just the slope. So that's the slope. So that's the answer, -1. Okay. So I just want to give you an example how to use this formula, because I'm gonna give you this formula in the exam. Again, I could just give you this one, dy dx equals dy dt over dx dt. But you will have to do this work that I did over here. Yeah, this work we did here. So I'm trying to save you time, but you can just do it like that. Okay, so that was about derivatives. And now get ready for the last two problems of the semester. Okay. Actually, two problems. We're gonna do two problems. So example, and I will get you very specific. You guys don't have to. I won't put that hard. I'll try to provide a lot of information so you just calculate the right thing. So example. Oh, okay. Let me give you another formula before the example. We can already know it, but so this is a formula. So it's a area formula. So if you want to find the area enclosed, no, the area of the region enclosed by a polar curve, you use this formula. It's integral between a and b of 1/2 f of theta squared d theta. So we're not going to deduce this one. This is area. Section area. Or area of a region. Enclosed by the curve. Okay. So let's see what this means. So this is angle theta equals A. This is theta equals B. And this is my radius. No, my radius formula, right? This is R equals F of theta. So you have to be a little bit careful here, because when you do this, so this angle is A, but this angle, the whole angle is B. So this angle is including already the A part, okay? But it's okay. So that's what it means. So you are finding this region enclosed by these guys between the two lines, A and B. Okay, so let's find, so example, find the area enclosed by one of the loops, by one loop of the four leaf rows. This is R equals cosine of 2 theta. That's the one that we just graphed, okay? And then it's for theta between minus pi fourths and pi fourths. So that one was this one over here. So we need to find the area of that is enclosed for this we need to find this area. Okay. As we saw, this angle is pi fourths. No, let me choose. This angle is pi fourths, and this angle is minus pi fourths. Minus pi fourths. But I'm giving it to you, so I'm telling you what you have to find the area. Just describing, because I said pi minus pi fourths and pi fourths. That's exactly the part of the rows you wanna, the area of the rows that you're gonna find. And then all that we need to do is find, and now we come to the first exam. We need to find the integral between minus pi fourths to pi fourths. So with this problem, I can ask, this problem will evaluate one chapter 6 and this chapter. So this is a good question. Of 1/2 f of theta squared d theta, and that is 1/2 integral between minus pi fourths 1/2 of cosine squared 2 theta d theta. And what we can do is when I get what do I have to have? I'm sorry, I put the half twice, sorry. So since this is symmetric, I can just choose between doing between 0 and pi fourths of cosine squared of 2 theta d theta. So it's enough to find the area of the first part of the rows, right? Because the other part is symmetric. So I can just do it between 0 and pi fourths. Now, this trick, we did it in your exam number 1, and we changed this guy to, but you'll have this formula. You'll change this guy to integral between 0 and pi fourths, and the cosine square of 2 theta can be written like 1/2 of 1 plus cosine of 4 theta d theta. Okay. So I'll let you practice, review this. So once you find this integral, you should get pi 8. So this is part of chapter 6. Okay. So now the last problem, this is the last, at least, new problem for the semester, is this one. So I want to give you also an R length nicer formula for polar coordinates. So for R length for polar coordinates. So we talked about it, right? So we said that this was the integral between A and B of, I give you this formula last week. Dx d theta square plus dy d theta square. So then, but then I'm gonna give you another formula that, you know, we're not gonna simplify it, but this is similar. So it's something you could save time. You use this formula. It will be r squared plus dr d theta square d theta. So this one is the formula. So we want to use this one for polar coordinates. Sorry. So let's do an example. Example. Find the length of the cardioid that is r equals 1 plus sine of theta. And this one looks like this. So this is the integral, and then you put r squared. So you have to do 1 plus sine of theta squared plus the derivative of r with respect to theta is cosine. So that will be cosine of theta squared d theta. And okay, this cardioid is between 0 and 2 pi. Okay, so I give you that one. Theta is between 0 and 2 pi. So when you break this out, so you'll get 0, 2 pi, then square root of 1 plus 2 sine of theta plus sine squared of theta plus cosine squared of theta d theta. And this gives you sine squared plus cosine squared. It gives you 1. So you got 0 and 2 pi. 1 plus 1 is 2. 2 plus 2 sine of theta. This theta, it gives you 1. So then you can use this, now that you have this integral, this integral with, well, we have learned is that integral with the square root are very hard, right? So you could use something like trapezoidal rule or something like that. So use trapezoidal rule. You can use some approximation of this. And then this should give you 8. Okay. So you see that there are ways to, we will use this section to act on integrals. But I will make it very difficult. I will make it very similar to what we have over here. Okay. Okay, guys. So my time is up. It's even went 3 minutes out. So I can stop here. So I will next Tuesday. That is next Tuesday will be December 1st. So we will have the sample final exam, so you guys know kind of how does it look. So some idea what kind of questions, how long, etc. will be. Try to study seriously for that, so you will do better in the real final. Okay, guys. So I'll see you on Tuesday.
There's no class on Friday?
Again?
There's no class on Friday?
Friday? No,
Yeah.
Friday is holiday. Thursday and Friday are holidays.
Okay.
Okay, happy Thanksgiving, everybody. So
Happy
yeah, try
Thanksgiving,
to,
sir.
yeah, thank you, guys. So
I
try
got
to
a question. Oh,
Yeah.
sorry. I got a
Yeah,
question. Do you have office hours before the end of the day, or is it?
Yeah,
you're gonna-
today, yes. Yeah, I have office hours today.
What time?
Same than always, 4:30 to 6, Tuesday and Thursdays, and Mondays.
Okay, I'll be there in a few hours. Thank you, sir.
Okay, sure.
Have a nice day.
Okay, you do. Okay, goodbye, guys. I'm gonna leave you.